This topic is about using definite integration to find areas under curves. So let's go straight to examples. So easy examples where you just need to evaluate definite integrals. So let's call this A. So A is the definite integral of from 2 to 1. 2 over x cubed can be written as 2x to the minus 3. So always change to index form first. Plus 3x, all integrated with respect to x dx. Now that I've got it on index form, all I need to do is integrate it. So as soon as I integrate, I change the integral sign to square brackets. So 2 stays there, x to the minus 3 increases by 1 to x to the minus 2. Divide by the increase, which is minus 2. Plus 3x becomes 3. X to the power of 1 increases to x to the power of 2. Divide by 2, which is the increase. And integrating between 2 to 1. So 2 to 1 written at the end of the square brackets. Let's simplify now. So 2 divided by minus 2 gives me negative 1. So it's minus x to the minus 2 plus 3 over 2x squared between 2 to 1. Now that I've simplified it, all I need to do is substitute my values in. So first thing I need to do is substitute 2 in. So minus 2 to the power of minus 2 plus 3 over 2 times 2 squared. Take away when you substitute 1 in, so take away minus 1 to the minus 2 plus 3 over 2 times 1 to the power of 2. Okay, so I get this case. So all I get, when I put the first square bracket into the calculator, I get 5.75. And when I put the second one in, I get 0.5. So 5.75 take away 0.5 is equal to 5.25. So that would be my answer for A. Part B. Okay, integrating between 9 and 4. If I turn everything to index form, root x is the same thing as x to the power of a half. Minus 6 over x squared is the same thing as 6x to the minus 2. Integrating with respect to x. Now that I've got in index form, I can integrate. So increase the power. So x to the power of 3 over 2 over 3 over 2 minus 6. X to the power of, increase the power by 1 minus 1 over minus 1. And at the end of the square brackets, we put 9 at the top, 4 at the bottom. So upper limit and lower limit. Okay, if I simplify this, I end up getting, so 1 divided by 3 over 2 is 2 over 3. X to the power of 3 over 2. Minus minus becomes plus 6x to the minus 1. And substituting 9 first and 4 in second. So when I substitute 9 in first, I get 2 over 3 times 9 to the power of 3 over 2 plus 6 times 9 to the power of minus 1. Take away from 2 over 3 times 4 to the power of 3 over 2 plus 6 times 4 to the power of minus 1. Okay, when I put the first part into first square bracket into the calculator, I get 18 and 2/3. Oops, 18 and 2/3, not 18 to the power of 2/3. So 18 and 2/3. When I put the second thing into the bracket, I get 41 over 6. Okay, when I subtract this, I end up getting 71 over 6. Okay, C. Okay, so for C, everything's already in index form, so I can start integrating straight away. So when I integrate it, I get x to the power of minus 3 plus 1 is 2 over 3. Divide by the increase, which is 3 over 3, plus 2x to the power of 2 over 2 minus x, integrated between 8 and 1. So I'm substituting 8 and 1 in there. If I simplify this, I get 3 over 2 x to the power of 2 over 3 plus x squared minus x between 8 and 1. So first I substitute 8 in. So 3 over 2 times 8 to the power of 2 over 3 plus 8 squared, take away 8. Subtract from 3 over 2 times 1 to the power of 2 over 3 plus 1 squared, take away 1. I just want to fix this 3 up because it doesn't look like a 3 there. Okay, when I put these into a calculator, for the first term I get 62. For the second term I'm getting 3 over 2. So 62 take away 1.5 is 60.5. Okay, again, let's evaluate some of the following definite integrals. So a is this one. So a is equal to, first thing I would do is I would simplify, so split up the numerator and simplify it. So I get x cubed over x, which is just x squared. And 2x squared plus over x gives you 2x dx. Now I will integrate it. So when I integrate it, I get x to the power 3 over 3 plus 2x squared over 2 between 3 and 1. When I simplify this, I get a third x cubed plus x squared between 3 and 1, which is the same thing as substituting first 3 in and then take away when you substitute 1 in. Okay, so 27 divided by 3 is 9. 9 plus 9 is 18. 18 take away, it becomes 4 over 3. 18 take away 4 over 3 is equal to 50 over 3. So that's my answer to part A. For part B, first thing I need to do is expand the bracket. So it's the same thing as integrating between 4 and 1. When I expand this out, I get root x times root x, which is x. Minus 3 root x minus 3 root x gives me minus 6 root x, which is minus 6x to the power of a half. And minus 3 times minus 3 is plus 9. So I end up getting this. It's already in index form, so now I can integrate it. So I get x squared over 2 minus 6x to the power of 3 over 2 over 3 over 2 plus 9x, substituting in 4 and 1, so upper limit 4 and 1. If I simplify this, I get half x squared minus 6 times 2 is 12. 12 divided by 3 is 4, minus 4x to the power of 3 over 2 plus 9x between 4 and 1. Substitute 4 in, so half times 4 squared minus 4 times 4 to the power of 3 over 2 plus 3 over 2 plus 9 times 4. Subtract from when you substitute 1 in, half times 1 squared minus 4 times 1 to the power of 3 over 2 plus 9 times 1. Now when you substitute this in, for the first term you get 12. For the second term you get 5.5. So 12 take away 5.5, which is equal to 6.5 as a decimal. Okay. Question 3, area bounded by curves. So here's an example 1, an area split by the y-axis. So if it's split by the y-axis, it doesn't matter. It's one section still, so you can integrate it as one integral. So find the area under the curve y is equal to 3x squared plus 2x plus 4, the x-axis, and the line x equals 1 and minus 1. So you can see the y-axis is in that region, but it doesn't matter. So all you're doing is integrating, oh, why did it keep changing? Integrating 3x squared plus 2x plus 4 dx between 1, which is upper limit, and minus 1, which is lower limit. So as soon as you integrate it, you get 3x cubed over 3 plus 2x squared over 2 plus 4x between 1 and minus 1. If you simplify it, you get x cubed plus x squared plus 4x between 1 and minus 1. Substitute in 1 first. Subtract when you substitute minus 1 in. Okay, so you end up getting 6 is the first term, and the second term becomes minus 4. 6 take away negative 4 gives you 10. So an area split by the x-axis. So let's look at this example. Find the area bounded by the curve y is equal to x times x minus 1 times x minus 3 and the x-axis. So if I sketch this out, I know it's a cubic, it's a positive cubic, and it goes through the origin, x equals 1 and x equals 3. It's a positive cubic, so it starts at quadrant 3 and ends up at quadrant 1. So it looks like this. We're trying to find the parts that are bounded by the curve and the x-axis. So it's basically this part and this part. Now one of them is above, so let's call this A, above the x-axis, and one of them is below the x-axis. So because it's two separate parts, we need to integrate it separately and then add it together. So when I'm working out A, what I'm integrating is between 1 and 0, I'm integrating x times x minus 1 times x minus 3 all dx. Okay, what I would do first out is I would expand this bracket. So let's do this here. So x times x minus 1 times x minus 3 is the same thing as x times x squared minus 4x plus 3, which is the same thing as x cubed minus 4x squared plus 3x. So to do this, all we're doing is integrating between 1 and 0, x cubed minus 4x squared plus 3x dx. Now that we've got in the right, obviously index form, I can integrate it. So I get a quarter x to the power of 4 minus 4 over 3x to the power of 3 plus 3 over 2x squared. Okay, between 1 and 0. So I need to substitute 1 in and then 0 in. So a quarter times 1 to the power of 4 minus 4 over 3 times 1 cubed plus 3 over 2 times 1 squared. When I substitute 0 in, I know I'll get 0, so minus 0. That's the same thing as a quarter minus 4 over 3 plus 3 over 2, which is 5 over 12. So this is A is equal to 5 over 12. I need to do the same thing with B. So with B, I need to integrate between 3 and 1. Okay, and it's again integrating x times x minus 1 times x minus 3, the same function. Now what I do know is I've already worked out the integral, so it's the same thing as a quarter x to the power of 4 minus 4 over 3x cubed plus 3 over 2x squared. And obviously I have to substitute 3 in and 1 and then subtract it. So it's the same thing as a quarter times 3 to the power of 4 minus 4 over 3 to the power of 3 plus 3 over 2 times 3 squared. Subtract when you substitute 1 in. So quarter 1 to the power of 4 minus 4 over 3 1 cubed plus 3 over 2 1 squared. Okay, when I've put the first part into the calculator, I get minus 9 over 4. And when I put the second part into the calculator, I end up getting 5 over 12. Okay, when I do minus 9 over 4 minus 5 over 12, I get minus 8 over 3. Now I'm getting a negative answer because it's below the x-axis. But I need to change it to a positive answer. So the area of B is equal to positive 8 over 3. So when it's below the x-axis, the area will be negative. So you just change the sign to a positive. So B is equal to 8 over 3. So the full answer will be A. I have to go somewhere here. The full answer, let's just put it here, is A plus B, which is equal to 5 over 12 plus 8 over 3, which is equal to 37 over 12. Okay, that is your final answer. 37 over 12 is your final answer. So the key thing to remember is any area under the x-axis will be negative, change to a positive. So always also calculate area split by the x-axis separately and then add it together to get your final answer. So what you do know is that section will be positive. Because this is below, it will be negative, okay? So you have to change the sign after calculating the integral, yeah? After calculating the integral. Again, for this one will be positive, so you can keep it the same. Here, you'll have to be negative. For this question, you'll have to work out 4 different sections and then add the final answer together. Okay, so change sign for this one as well. So the important thing is areas under the x-axis will be negative. Always change the sign to a positive, and separate sections always calculate separately and then add the final answer together. Okay, let's do some examples, a bit more complicated examples. The graph shows a sketch of part of the curve C with the equation y is equal to x times x plus 3 times 2 minus x. The curve C crosses the x-axis at the origin at points A and B. Write down the x-coordinates of A and B. So because we know the function is equal to y is equal to x plus 3 times 2 minus x, that means the roots x times x plus 3 times 2 minus x. The roots are x equals 0, x equals negative 3, and x equals 2. That means a, because a is in the negative x section, it must be a must be equal to negative 3, 0, and b must be equal to 2, 0. So the x-coordinate of A is minus 3 and x-coordinate of B is 2. Okay, it says the finite region shown shaded is bounded by the curve C and the x-axis. Use integration to find the total area of the finite shaded region. The first thing I'll do is, because I know y is equal to x times x plus 3 times 2 minus x, I'll just expand that bracket first to get my function expanded. So y will be the same thing as minus x squared, minus 3x plus 2x gives me minus x, and then I get 3 times 2, which is 6. So when I expand it out, I get minus x cubed minus x squared plus 6x. So it's the same thing as integrating. First thing, let's call it a here and b there. Because a is below the x-axis, I'm expecting a negative answer. I'll have to change to a positive afterwards. So for a, I'm integrating between 0 and minus 3. So 0 and minus 3. Minus x cubed, so the expanded form, minus x squared plus 6x, all dx, which is the same thing as minus x to the power 4 over 4 minus x squared over 3, so x cubed over 3, plus 6x squared over 2. Between 0 and minus 3, substituting in 0 and minus 3. Let me just write that out neater. X cubed, which is the same thing as minus a quarter x to the power 4 minus a third x cubed plus 3x squared, between 0 and minus 3. Okay, so I first need to just substitute 0 in. Now when I substitute 0 in, I know straight away I'm going to get 0. So the first term will be 0. And I just substitute in negative 3. So minus a quarter times negative 3 to the power of 4 minus a third times minus 3 to the power of 3 plus 3 times minus 3 all squared. Okay, when I put that into my calculator, I get 0 minus 63 over 4, which is negative 63 over 4, but we changed to a positive. So we did get a negative answer, but we changed to a positive. So 63 over 4 is my answer for A. Now when I do this for B, so B, I'm integrating between 0 and minus, no, not 0 and minus 3, not the same thing. So B is between 2 and 0. 2 and 0, minus x cubed minus x squared plus 6x, the same function. So I've already integrated this, so I can just write minus a quarter x to the power of 4 minus the third x cubed plus 3x squared. Substituting in 2 first, subtracting from when we substitute 0 in. So the same thing as minus a quarter times 2 to the power of 4 minus the third times 2 cubed plus 3 times 2 squared. Take away, when you substitute in 0, we're going to get 0. If we input this into a calculator, we're getting 16 over 3, which is positive, which makes sense because B is above the x-axis. So the final answer is A plus B, which is equal to 63 over 4 plus 16 over 3, which is equal to 253 over 12. And that would be a final answer. Next question. F of x is equal to minus x cubed plus 4x squared plus 11x plus minus 30. The graph shows a sketch of the part of the curve with equation y is equal to blah, blah, blah. A. Use a factor theorem to show that x plus 3 is a factor of f of x. So if x plus 3 is a factor, then we need to calculate f of minus 3. So if I calculate f of minus 3, so f of minus 3 is equal to minus 3 cubed plus 4 times minus 3 squared plus 11 times minus 3 take away 30, which is equal to, gives me positive, minus 3 cubed is negative 27, but multiplying by minus 1 gives me plus 27. 4 times minus 3 all squared is 36. Take away 33, take away 30, which gives me 0. Since f of minus 3 is equal to 0, x plus 3 is a factor of f of x by the factor theorem. Okay, that's part A done. Part B, write f of x in the form x plus 3 times ax squared plus bx plus c. So I'm going to do a polynomial division. So x plus 3 divided by minus x cubed plus 4x squared plus 11x minus 30. So it's a negative x squared here. So I get negative x squared times negative x is negative x cubed. 3 times negative x squared gives me negative 3x squared. I'm subtracting these two cancel out. 4x squared take away negative 3x squared gives me 7x squared plus 11x minus 30. X times what gives me 7x squared is a positive 7x. So I get 7x times x squared is 7. So 7x times x is 7x squared. 3 times 7x is 21x. I'm subtracting this. So these two cancel out. 11x take away 21x is minus 10x minus 30. X times what gives me minus 10x is minus 10. Minus 10 times x is minus 10x. 3 times minus 10 is minus 30. When I subtract them, they cancel out. So that means f of x is equal to x plus 3 times minus x squared plus 7x minus 10. C, hence factorize f of x completely. Okay, so C is f of x is equal to x plus 3 times minus x squared plus 7x minus 10. I take the minus out, x plus 3, I get x squared take away 7x plus 10. And that can be factorized to x minus 5 times x minus 2. So that's fully factorized. D, hence determine the coordinates. Hence determine the x coordinates where the curve intersects the x-axis is all the roots of the equation. So dx is equal to negative 3, x is equal to 5, and x is equal to 2. Okay, hence determine the total shaded area shown by the sketch. Okay, total shaded area. So that means this is minus 3, this is 2, and this is 5. So let's call this A, and let's just call this B. So we have to do E. Let's do E here. Okay, so first thing I need to work out is A. Let's do B first because it's positive, because it's above that x-axis. So let's do B first. So integrating between 5 and 2 minus x cubed plus 4x squared minus 11x minus 30 all dx. So as soon as I integrate it, I get minus a quarter x to the power of 4 plus 4 over 3x to the power of 3 minus 11 over 2x squared, take away 30. I feel like I copied the question right down. Oh, this is a mistake here. It should have been a plus 11x. So plus 11x plus 11 over 2. So be careful with your signs. So substituting in 5 first and then 2. So when I do this, I get minus a quarter times 5 to the power of 4 plus 4 over 3 times 5 to the 5 cubed plus 11 over 2 times 5 squared, take away 30. And then I need to substitute in 2. So minus a quarter times 2 to the power of 4 plus 4 over 3 times 2 to the power of 3 plus 11 over 2 times 2 squared. 2 squared, let's write that out properly. 2 squared, take away 30. Did I put 30x there? Oh, 30x. So let's go back. Okay, the third minus 30 integrates to minus 30x, yeah? So minus 30 times 5 here. Minus 30 times 5 here. Okay, and minus 30 times, we're substituting 5 first and then 2. Minus 30 times 2 here. Okay, when we put the first square bracket into the calculator, we get minus 25 over 12. So that's the first square bracket. Subtracted from the second square bracket, when you put the second square bracket in our calculator, we get minus 94 over 3. When we put this all into a calculator, we get 117 over 4. That's not a final answer, so that's just A. Okay, now we need to calculate A, which is below the x-axis, so we're expecting a negative answer for this one. A is the integral between 2 and minus 3 of minus x cubed plus 4x squared plus 11x minus 30 dx. So we end up getting, we've already integrated this, minus a quarter x to the power 4 plus 4 over 3x cubed plus 11 over 2x squared minus 30x between 2, substituting 2 in and minus 3, which is the same thing as minus a quarter times 2 to the power of 4 plus 4 over 3 times 2 cubed plus 11 over 2 times 2 squared minus 30 times 2, subtracted from minus a quarter times minus 3 to the power of 4 plus 4 over 3 times minus 3 all cubed plus 11 over 2 times minus 3 squared minus 30 times minus 3. Okay, when we put this into a calculator, the first bracket gives us minus 94 over 3. Subtracted from the second bracket gives us 333 over 4. And we put this into our calculator, we get negative 1375 over 12, which makes sense because A is below the x-axis, so turn it to a positive number, which is 1375 over 12. So A plus B is equal to 117 over 4 plus 1375 over 12, which gives us 863 over 6. Next question. Find the shaded area. So the first thing I need to do is find the point A and point B. And what I do know is they are turning points. So we know that dy dx is equal to 0 at A and B. So first thing I need to do is find dy dx. So dy dx, we differentiate y with respect to x, I get 3x squared minus 16x plus 20. So that means I need to make 3x squared minus 16x plus 20 equals 0. So if I factorize it, I've got 3x in one, x in the other. I must have a minus 10 here and a minus 2 there, which means x is equal to either 10 over 3 or x is equal to 2. So 2 is smaller, so that means this one is 2 and B is 10 over 3. So what I'm going to do is first is I'm going to find this bit. Okay, now this bit is easy to find because what I need to do is I just need to integrate. So let's call this not A, but let's call it R1, yeah? So for R1, I need to integrate between x equals 2 and x equals 0. The function x cubed minus 8x squared plus 20x. Okay, so when I integrate it, I get a quarter x to the power of 4. A quarter x to the power of 4 minus 8 over 3 x cubed plus 20 over 2, which gives me 10x squared. Between substituting 2 in first and then 0, which is the same thing as a quarter times 2 to the power of 4 minus 8 over 3 times 2 cubed plus 10 times 2 squared. When I substitute 0 in, I know I get 0. So I get that case. So quarter times 2 to the power of 4 is 4, take away 64 over 3 plus 40 gives me 68 over 3. So that's region 1. Okay, now the triangle, I know this is 2 and this is 10 over 3. So this is going to be 10 over 3 take away 2, which is equal to 4 over 3. Now, if x is equal to 2, so when x equals 2, y is equal to 2 cubed minus 8 times 2 squared plus 20 times 2, which is 8 take away 32 plus 40, which is 16. So that means this is 216. So the height of this and triangle is 16. So area of triangle, so we've got this triangle, which is 16 this way and 4 over 3 this way, is equal to half times base times height. Half times 16 times 4 over 3, which is the same thing as 32 over 3. So that means the total region, so R, which is the whole thing, R is equal to R1 plus area of triangle, which is equal to 68 over 3 plus 32 over 3, which is equal to 100 over 3. Next question. So it says the curve C has equation y is equal to x squared minus 5x plus 4. It cuts the x-axis at points L and M as shown in the diagram. Okay, so we have y is equal to x squared, y is equal to x squared minus 5x plus 4. That factorizes to x plus 4, x minus 4, x minus 4 times x minus 1, which means x-intercepts are, roots are x equals 4 and x equals 1. So that means L is 1, L is 1, 0 because it's a smaller number, and M is 4, 0. Okay, so what we can do is, if I make this into a triangle, okay, then area of triangle, is equal to, so the base is 4 take away 1, which is 3, and the height is 4. The height is The height is 4. So it's 4 times 3 divided by 2. So I made a mistake there because this M is 4, 0, but this is 5. So from there to there is actually 5 because it's 4. Oh, let's explain this again. So M is 4, 0. This N is 5, 4. So this triangle is of length 4 here. So this will be 4. Okay, so area of triangle is 4 times 4 divided by 2, which is 8. Okay, so the area of this triangle is 8. What I need to do now is work out the area under the curve here. So let's call this R1. Then let's call it R1 like this. Then R1 is the integral between x equals 5 and x equals 4 of the function, which is x squared minus 5x plus 4 dx, which is the same thing as a third x cubed minus 5 over 2x squared plus 4x, the upper limit being 5, the lower limit being 4. So I need to substitute in 5 first, minus 5 over 2 times 5 squared plus 4 times 5, subtracted from a third times 4 cubed minus 5 over 2 times 4 squared plus 4 times 4. When I substitute into my calculator this, I get negative 5 over 6 for the first term, subtracted from negative 8 over 3, which gives me 11 over 6. Okay, all I need to do now is area of R is area of triangle take away R1, which is 8 take away 11 over 6, which is equal to 37 over 6. So that would be my answer. So I'm just going to explain the triangle part again. So the area of triangle, we know the base is 4 because it's n is, the x coordinate for n is 5 and the x coordinate of L is 1. So 5 taken away 1 is 4. So the base is 4. And the height is 4 because the y coordinate of n is 4. Next question. Okay, in the diagram above, the curve has equation y is equal to 6x minus x squared, and the line L has equation y equals 2x. Find R. Okay, so the first thing I need to do is find the points where they intersect. So I've got y is equal to, so I solve it simultaneously, y is equal to 6x minus x squared, and y is equal to 2x. Because y is the subject of both formulas, that means 6x minus x squared is equal to 2x, which means x squared minus 4x must be equal to 0, which means x times x minus 4 is equal to 0, which means x equals 0 and x equals 4. So that means this point is 0, 0, and this point is 4, and y is 2 times x, so 4, which means y will be equal to 0, and 2 times, using the second equation, y equals 2 times x, y will be equal to 8 in this case. So that's one answer, and that's another answer. So 4, 8. Okay, so what I need to do first is the area of this triangle. So area of this triangle. So area of triangle is equal to base, which is 4 times the height, which is 8, divided by 2. So you can clearly see this is 4 and this is 8, which gives you a value of 16. Okay, now if I work out the area of the integral, so integrate the area under the curve all the way up to x equals 4, then I subtract the area of the triangle, I'll get R. Okay, so if I work out the orange part, which includes, if I include the orange part, which also includes a triangle and area R, yeah? So I'm integrating first between 4 and 0, the area under the curve. So not the area under the straight line, area under the curve, 4 and 0. 4 and 0, 6x minus x squared, or dx, which is the same thing as 6x squared divided by 2, which is 3x squared minus a third x cubed between 4 and 0, which is the same thing as 3 times 4 squared minus a third times 4 cubed. When I substitute 0 in there, I know I get 0, which means I get, if I put this into my calculator, I get 80 over 3. Okay, so now its area of R is equal to this area that I worked out. So let's call this let's call this the orange part, is equal to the orange part take away the area of triangle, which is equal to 80/3 take away 16, which is equal to 32/3. Okay, last question I'm going to go to. The shaded area under the curve of the function f of x is equal to 3x squared minus 2x plus 2, bounded by the curve, the x-axis, x equals 0 and x equals k. So this part is equal to 8. Work out the value of k. So that means when we integrate between k and 0, 3x squared minus 2x plus 2, all dx, we get getting 8. So let's integrate first. So I get 3/3 x to the power 3, which is just x to the power 3, minus 2/2 x to the power 2, which is just x squared, plus 2x between k and 0 is equal to 8. Which means when I substitute k in, k cubed minus k squared plus 2k, subtracted by, when I substitute 0 in to this term, I get this expression, I get 0. Minus 0 is equal to 8. So I've got k cubed minus k squared plus 2k is equal to 8, which means k cubed minus k squared plus 2k minus 8 equals 0. So let k be equal to 2, then 2 cubed minus 2 squared plus 2 times 2 minus 8 is equal to 8 minus 4 plus 4 minus 8, which is equal to 0. Therefore, k minus 2 is a factor by the factor theorem. Okay, so I'll just go over here. So if I do k cubed plus k squared, sorry, minus k squared. So minus k squared plus 2k minus 8 divided by k minus 2. K times what gives me k cubed is k squared. So I get minus 2k squared. If I subtract it, I get k squared plus 2k minus 8. K times what gives me k squared is k. K times k is k squared. Minus 2 times k is minus 2k. When I subtract it, I get 4k take away 8. K times what gives me 4k is 4. 4 times k is 4k. Minus 2 times 4 is minus 8. You cancel that, give me 0. Which means k cubed minus k squared plus 2k minus 8 is equal to k minus 2 times k squared plus k plus 4. Now this does not have real roots. Real roots, as the discriminant is b squared, 1 squared minus 4 times 1 times 1. 1 minus 4 is minus 3, so discriminant is equal to negative 3, which is less than 0. Okay, so it doesn't work out. So which means k minus 2 is the only real factor, which means k is equal to 2 is only real root. Therefore, k is equal to 2.